In this video, we're going to learn how to use prime factorization to find the GCF and LCM of two numbers. So, fact, the product of two numbers equals the product of their GCF and LCM. Okay, so we're going to use this idea and prime factorization to find the GCF and LCM without listing all the factors and without listing a whole bunch of multiples. We will have to find the prime factorizations of the two numbers though. So we'll use prime factorization to determine all the common prime factors of two numbers and find their product to determine the GCF. So here's an example. 8 is equal to 3 factors of 2. That's its prime factorization. 12 is equal to 2 times 2 times 3. That's its prime factorization. They share 2 factors of 2, and so we multiply. You include repeated factors. You multiply those 2 factors of 2, and their GCF is 4. Okay, now you can find this by listing all the factors of 8 and 12 as well, but this way is more direct. The numbers are kind of small, so you may have noticed this, but this will be an excellent skill when the numbers are larger. Then we have this really nice fact that the least common multiple is equal to the product of the two numbers divided by their GCF. Okay, now there's a way to use these prime factorizations to find the least common multiple in a different way, but it's easier to find the GCF, and then if we just use this process, we can get the LCM. And remember, that's the one where you could be making lists for a really long time since the lists go on forever. So in our example, we found the GCF of 8 and 12 was 4. So to find the LCM, we could take 8 and 12, multiply them, divide by their GCF, and find their LCM that way. Okay, so let's look at an example. So we're going to go through this process to find the GCF and LCM of 30 and 24 from the start, meaning we're going to find the prime factorizations. We'll leave them in factored form. So 30, I'm going to write that as 3 times 10. 3 is prime. Still have to factor 10. 10 is 2 times 5. Okay, I'm going to put the factored form in increasing order. 2 times 3 times 5, and that will help you compare it to the other factored list. Now 24 is 2 times 12. Again, it doesn't matter which factor pair you start with, you'll always get the same result. 12 is 3 times 4. 3 is prime. And 4 is 2 times 2. Okay. So the prime factorization of 24, there's 3 factors of 2 and 1 factor of 3. So list of common prime factors. Well, notice they each have at least 1 factor of 2. Okay, this one has more factors of 2, but 30 only has 1. It says to include repeated factors. We don't have any repeated factors here. And they each have a factor of 3. Okay, so we're finding what they have in common, and then the GCF is the product of these 2 factors. So 2 times 3 equals 6. So the GCF of 30 and 24 is 6. Now to find the least common multiple, we know that we could find the product of 30 and 24, so take your numbers, 30 times 24 divided by their GCF, which is 6. And I write it this way, but you could also write it as 30 times 24 and in the end divide by 6. In this case, it actually doesn't matter in what order you divide, despite the order of operations, but that's a long story. So let's just multiply the numbers. 30 times 24. Then we divide by 6, and we get 120 is the least common multiple. Okay? And I want you to appreciate finding multiples of 30 wouldn't be that hard. 30, 60, 90, 120. Be a little bit of a pain with 24. You'd have to find 5. The numbers would get pretty big. So this process is very useful when the numbers are larger. And we're going to do one more example with 54 and 90. So 54, I see that it's even because it ends in 4, so I'm going to divide it by 2. And I happen to know that this is 2 times 27. If not, just check on your calculator. 27, well, that's 3 times 9. You might know that from your multiplication facts. And again, if you don't know, you just check the prime factors less than it. And 9 is 3 times 3. Okay, should have left more room here. So the factored form, we have 1 factor of 2 and 3 factors of 3 is the prime factorization of 54. Now let's look at 90. I think we did 90 a few times. 2 times 45 is one way to start. 2 is prime. 45 is 5 times 9. 5 is prime. And 9 is 3 times 3. We don't always write the last one sideways. I'm just running out of room, if you're wondering why I'm doing that. Okay, so we have 1 factor of 2, 2 factors of 3, and a factor of 5. So we have 2 times 3 times 3 times 5. Okay. Now let's list all the common prime factors. So I'm going to start here, okay, and then I'm going to compare to this list. So here we have 1 factor of 2 in common. Okay, this has 3 factors of 3. Here we have 2 factors of 3. I'm going to color code these so you can see how the repeated factors work. So this 3 matches with this 3, and this 3 matches with this 3. Okay, I don't have another 3 that I haven't already identified. Okay, and this has a factor 5, but 54 does not. So basically, go through your first list and match up any common factors. They each have 2 factors of 3, and you need to include that repeated factor. So our list is 2, 3, 3. The GCF is the product of these numbers. So 2 times 3 times 3 is 6 times 3, which is 18. So their greatest common factor is 18. And to find the least common multiple, I'm going to take my numbers 54 times 90 and divide by the GCF, which I already found. So 54 times 90 divided by 18. So their least common multiple is 270. Again, somewhat of a large number, so it's good to have this process.